So what is an A surface now? Now we will come to our main topic of today. So you can see here the visible surface and the aesthetic surface, as simple as that. Okay. So when you see a car, what all you can see is an A surface. Maybe it from the inside, maybe it from the outside. Okay. Am I clear? Anything that you can see is an A surface. It is not actually an abbreviation of aesthetic, but yes, for your sake, you can, or when I was learning, I assumed it as an class aesthetic surface. A surface stands for aesthetic, but let me be clear, it doesn't stand for aesthetic. Okay. It is not standing for aesthetic, but for you to remember it, you can, or for you to be prompt. And when someone asks you in the interview what is a surface, to for you to remember it, you can use this trick that a surface is for aesthetics. So any visible surface, any aesthetic surface you feel you see is an a surface. Okay. So what is aesthetics? If anyone can answer what is aesthetics, basically aesthetic is basically something pleasing to your eyes. Okay. So boys may understand what is aesthetics. So anything which pleases you. Now for girls, so any pink color is aesthetic for them. I don't know why, but yes. So basically, I'm trying to give you a visual kind of sense that anything like a shape of the car that attracts your eye. Wow, that's an aesthetic car. If someone comes to your room and they say, "Wow, your room is so well arranged, it looks so aesthetic." Okay, so aesthetics is basically what you see. As simple as that. Visible surface, what you can see is aesthetics. Now, just opposite to that, the surface that you cannot see is B surface. It is the invisible surface. So what is visible? So what is invisible? I will basically just note this down in your brain. I will be showing how the visible surface and invisible surface looks like, what aesthetic surface actually means, and like you had an assignment last week, right? You you show some B surfaces and A surfaces, right? So the remote, some Praveen sir had showed some remote, right? So the part of the remote that you can see from outside is the aesthetic surface, and inside there will be some ribs, then there will be some bosses, screw bosses, and all. So all those engineering things are done on the B surfaces, which is basically not visible, and that surface is not very aesthetically pleasing to see also. Okay, so basically a surface is the visible surface, B surface is the invisible surface or the inside surface, you can say. Then A surface is with textures. So sometimes you need a grip to an surface. Aesthetic and ergonomics is also one concept. So ergonomics is when any part comes in contact with the human body and designed according to that, that is called as ergonomics. If you can see, if any handling thing, they have the finger slots over it. Okay, anything which is having like you can place your fingers very easily, there are slots for your fingers, so that is an ergonomics. It is called as ergonomics of that part. So when you sit on a seat, the seat is designed according to your sitting posture, so it is called as ergonomic of that seats. So aesthetics and ergonomics both are part of a surface. So where there is human contact and there is grip needed, there is textures. You can see on any plastic part, there is a rough or the graining, it is it is dotted. Very fine dots are there. So you don't slip over it. You get a good grip, or you can have a good, like the dashboards are there. Sometimes it is dotted. So that is called as grained surfaces. Okay. Yeah. So again, the digital sculpture, which I mentioned, people working on in the studio department who will be working on the clay modeling, then the scanning, and then the alias software. So those people are called as digital sculptures. So surface provided by digital sculptures is called as a surface again, and surface developed by us. Okay, you can see in the next point. Surface needed to be created according to the class of surface done by the design engineers is called as B surface. So what we are going to contribute is towards the engineering side, towards the manufacturing sides, and making the B surface. So you will all come to know how the A surface and B surface are, how the A surface is received and B surface is made. I am going to show it to you after some time. So you can see they don't have features like ribs, stamps, etc. So a surface cannot have anything on the surface because it is an aesthetic surface. So even defects cannot be shown on the a surface. So a surface needs to be as it is as given by the sculptor. So please note it down for whole life. You cannot make changes in a surface. It is not your job. You can suggest changes, and the studio people will make the changes and give it to you back. So it is called as design iteration. Okay. You have no right to change the A surface. Even if it is not manufacturing feasible, you have to report that to them that, sir, you have given this surface, but this is not manufacturing feasible. Please design something else and give so that we can make it manufacturing feasible. Okay. So A surface modifications are always done by the sculpting engineers or the basically CAS team, which is called as Class A surface team. Okay. So studio people, we don't do any changes from the data which we receive from the customer. We just do our part and make the part manufacturable. Okay. So basically, a surface has a curvature continuity. I will talk on what is curvature continuity. Okay. So you can see surfaces which may have tangential continuity or curvature continuity. Both kind of continuities are okay in B surface. Okay. So A surface is directly taken from the scan data. B surface is converted from A surface. Okay. So B surface has all the engineering features on it. Okay. So hope we are clear on this. You will get more idea as we will go to the CAD portion. Okay, I'll take you there. You can see here. If you can look closely, you can see blue lines are there, the meshing lines. So these are all small patches. Okay. And this is the STL data, or you can say the CAS data, or the A surface which we are getting from the scanning data. You can see here. Cloud point data. I have mentioned in the previous slide. Okay, you will be having the cloud point data. From the cloud point data, these surfaces are generated and they are given to you. Basically, you cannot make changes in the surface. I'll show you here. See, this is an STL input. I cannot make any changes in this. You can see just one surface. If I select this, the whole surface is getting selected. So I cannot make any changes. Basically, I should not make. I can make changes, but this surface is not going to change. It will show operations. Okay. So we'll come to that. So see, this is kind of STL surface or A surface. From STL surface, A surface is made. STL surface is basically the cloud point data. And from STL surface, you can see the output data depends on the type of 3D scanners. So what type of 3D scanner is being used? So the cloud point data will be in that. So STL is an identical point cloud data. So what is point cloud data? There will be many continuous points from here till here. There will be lakhs of points, and those all points will look like a cloud to you. Okay, so it is called as cloud point data. So you see here, there will be empty spaces between the points. So now if you watch very closely, all these nodes will have points. This one. So these points are joined by the surfaces, and the meshing surfaces is created, and that surface is called as A surface. You can memorize it or you can think it in that form. Okay, you can see here. STL is an identical to point cloud data. Difference is that STL format is filled with triangular surfaces occupying the empty spaces. Okay. So this, once you get the point cloud data, the space between the points is filled. This is very zoomed. Okay, means this can be only this much patch. Only this, even the pointer of the mouse is there. Only that much patch is this patch. Is totally zoomed in. Okay, so when you fill the gaps between those points, you get an STL data, and from that data, the A surfaces are created. Okay. So you can see here STL from they are filled with the triangular surfaces occupying the empty spaces between the points. Fewer the points, larger the triangle. As simple as that. So if there is one point here, one point here, one point here, directly a big patch will be there. So it is not the case. So how many points are there? That much triangles are there. Okay. So this is the meshing surface. So from this STL, they make CAD surfaces, and we get that input. Okay. See here again, the clay model, cloud point data, A surface and B surface. So basically, our work is there only in the last part. These steps are of studio engineers. Okay, you can see here by using alias classes surfaces created by exporting IGS and step files. Okay, so these IGS format, step format, STL format, these are like daily base. These are the words and the format files, the files or the format of the files that will you will be using on daily basis as a design engineer. Okay, so don't take stress of these points. You will be handy with those things, not a big issue. Okay. So moving forward, so you can see there are some defects. So while importing IGS files, we may face some defects in the class A surface. So what are the common defects? Okay. So there is discontinuity in the surfaces while there is a patch missing somewhere. Okay. Or there are some joining errors. Or if there is a patch missing somewhere, there will be two patch on the same surface or the same points. So they found some topological errors also. So this is what studio people will make ensure that the part is free of any defect. Yes, we also can do it when it comes to us. We can show to them that there are these defects, and then they remove it and then they give us back. So basically, this is a give and take thing. Okay, you can see here most of the time when the shapes are not too complex, there are no much too many defects. As simple as that. Okay, when there is just a curve, the big patch can do. When there are very undulations in the part, at that time the shape is a bit complex. So at that time there can be possibility of more errors. Okay, so when there are no patches available in between, so we use some uh, operations like multi-section blend and all those surfacing operations, and we fill those patches. I will be showing you one by one how we are going to use those things. Okay. Now see, what is the importance of A to B conversion? So class A surface is mostly the skin of the car. Now you may have understood. So what you see, what is visually available for you is called as A surface. So basically we call it a skin. Okay. So engineering study. Now what is engineering study exactly means? So what is a job of engineer? So job of studio people or job of the designer, or you say designer. Design engineer and designer are two different things. Okay, guys, please note it down. For whole life, you are not a designer. You are not a car designer. You are a design engineer. So these two are very different concepts. So designer sits in a studio, and design engineer does the engineering of the part. So basically, studio people's work is our input. Okay, so we take that input and we engineer the part, means we make it manufacturing feasible, we make it fitment feasible. Only manufacturing feasible does not work. Okay, so now you may be knowing now, like there are GD&T, there is geometrical and tolerances. So when you manufacture a part and there is a deflection in the dimensions, so that part cannot be assembled. Okay, if the part cannot be assembled, it is for no use. Okay, it will be scrapped. That's why the part should be manufacturable and should be fitment feasible. So both the things is called as engineering. Okay. So basically all engineering features are being pasted on the B surface. So strengthening ribs, mounting clip, reinforcements, everything is on B. Basically everything you have to do is on the B surface. A surface is just like what we say. A surface is the aesthetic surface. We cannot change it. We cannot do any work on the A surface. So bacha kya? What is remaining is B surface. So we have to do that with the packaging study. All the things are done on the B surface. The cutting, the splitting, the extrapolating, the stitching, whatever you do it on the B surfaces. Okay. So making it manufacturer feasible. So B surface only is to be made manufacturing feasible. So now we will talk on that. Okay. So you can see here importance of A to B conversion. So this is the styling data. You can see the whole car is there. So this is the style data. So cast surface, A surface is also called as style surface because it is the style statement of the car. We call it as style surface. So you make a note of this word also. A surface is also known as the styling surface or style surface. So you will be using this word interchangeably throughout your career. Sometimes you may call it A surface, sometimes you may call it style surface. So it is in that way. So you can see here, first the styling data is there, then the architectural layout study is done. Okay, then the master sections are created. If you can, don't know, clear is this? You can see here. This is a master section. Okay, so you can see this is a plastic part. This is a clip. Okay, this is a 2.5 part. I think this is a master section for roof. This is the windshield. Okay, see, this kind of sections are developed, and these sections help you to know what kind of part are we going to manufacture. Okay, so what is our role is making the sections and then making it feasible. Okay. Then once you have the master section study, this is the master section. Once you do the study, then you can go for design of the CAD design. So you can see here. So this is what a CAD design looks like. Okay. So this is the steering column slot. This will be the instrumental. This will be the instrumental cluster. This is the center console. This is something audio, video, or something that kind of thing. The LCD screen or LED screen will be here. There will be some AC controls over here. These are the AC vents. These are also vents. So this is the end cap cover. So this total part is called as IP or dashboard, instrumental panel we call it as, and this center is called from here. The below part is called as center console. Okay, center console will have the gearbox, lever, and some armrest and all these things. Okay, so This is what a CAD model looks like. You can see there are patches. So all this is A surface. Everything is styling. Everything. Each and every surface you are seeing is styling. Now you can see this is going inside and you can see the backside surface over here. This is the B surface. It is inside. Okay. You can see this inside part. This is all the B surfaces. You can see some fixations kind of things here. You can see some fixation layer. So these are the B surfaces. I will show you what how the B surfaces are. Yeah, so after making the 3D, so basically the 3D design is then assembled on the fixture and the final part is done and this final part is taken to the assembly. Okay. Now this is for the cup holder is an example. So check the A class for quality, offset the A surface, patchwork to be done in the offset is not taken directly, then wall thickness is added, then join A class, B class, C class together and convert the surface. So this is the procedure to make a closed volume. So we make B surface to make a closed volume.